Okay, this is the Vectors Test 2 free response explanation. For those of you who want to go back over this at home, a model airplane heads due west at 1.50 meters per second, while the wind blows toward the south at 0.75 meters per second. Use a protractor and ruler to draw the velocity vectors and find the resultant velocity of the airplane. Use the scale 1 centimeter is equal to 0.25 meters per second. Okay, so here's our north, south, east, and west crosshairs that I refer to. So the first part of it says it's heading due west, so that would be directly to the left. And for every 1 centimeter is 0.25 meters per second. So 0.25 will go into 1.5 6 times, because we know from doing money, a quarter, to get $1.50 in quarters, we need 6 quarters. So we're going to line up our protractor with 6 centimeters. I'm going to put the 6 right at the 0, 0, and draw a line 6 centimeters west. Okay, so that's our 1.5 meters per second west. And then it says the wind blows south at 0.75. So on our scale, that would be 3 centimeters, because it takes 3 quarters to go into 0.75. So starting at the end of our, and I kind of lined up this line here with this line to make sure I'm sort of parallel, because that can have a little bit of a difference. So 3 centimeters south. Okay, that's 0.75 meters per second. So now you draw your resultant vector from here back to the 0. And if you've lined it up correctly from the 0, you can measure the centimeters here. It comes out to be about 6.7. Well, if I were to multiply that times 0.25, I've already done that in the calculator, so that would make it 1.675 meters per second. We would round that up to 1.7 meters per second. Because this is a right angle, you could also do the Pythagorean theorem. C squared is equal to 1.5 squared plus 0.75 squared. So 1.5 squared is 2.25, and 0.75 squared is 5625 plus 2.25 is 2.8125. Take the square root of that. Second square root, second answer equals, which comes out to be 1.677, which is very close to what we came out with by measuring our centimeters. So we're still at 1.7 meters per second. So this is just 2 ways you can get the resultant vector from a right angle. The next one we have down here is not a right angle, so you can't use it as the Pythagorean theorem. Okay, but the next question says the bearing angle of the resultant velocity. We always start from north, which is our 0 degrees. We know east is our 90 degrees, and south is 180 degrees and west is to 70 degrees. So you move in a clockwise fashion from 0 until you hit the resultant vector. Okay, so we know that so far here this is 180, so I need to know how much more past 180 this resultant vector is. So I'm going to line up my protractor here. Make sure all the lines are even. My dot is right over the crosshairs, so this line crosses at about 60. It's looking like 63, 64 right here. So we'll say plus 64 degrees, so that's 244 degree bearing angle. Okay? Let's look at the bottom one. Hector goes on a short hike. He goes 40 meters bearing 45 degrees, then 40 meters due east. Use a protractor and ruler to draw the displacement vectors and find the resultant displacement of Hector. Use the scale. 1 centimeter is equal to 10 meters. Okay, so Hector goes 40 meters, and on our scale, he's going to go 4 centimeters, but he's bearing at a 45 degree angle. So this is our 0, this is our 90. Well, we know it's halfway in between, but we're not going to just, draw a line halfway between, even though we might be pretty good at it. We're going to mark the 45. So by lining up our protractor here, my dot open hole there is at the crosshairs. My protractor is lined up along this line. So this is our 0. Here, right here is our 45. So I'm going to put a little mark here and here on this side. Just gives me 2 marks to help line it up. Then I'm going to put my 0 degrees, or 0 from my centimeters at the crosshairs, and then I'm going to line up my protractor with those marks. It says I'm at a 45 degree angle, but I don't want to draw a line all the way up to these marks. This is just helping me get lined up for the 45 degree angle. So now we said that he was only going to go 4 centimeters. This is 4 centimeters. So that's our 40 meters at a 45 degree angle. Do without these now. Okay, and then he's going 40 meters due east, so that would be completely to the right. Again, 4 centimeters. We put 0 where that ended. 4 centimeters there. Okay, so that's like right on the line, so it's kind of hard to see where that ended. Okay, and now we're going to line up the start to end. And that's my resultant vector. And I can also look at the measurement of it. It's about 7.5 centimeters, which according to our scale would make it 75 meters. So our answer here at the bottom then is 75 meters is the resultant displacement. But now we need to find what angle is that headed. So we want to find it starting from the 0 to the resultant. Okay. Again, I'm going to put my protractor here, line it up with 0, and my line is long enough now to cross here It looks like it's crossing, right, this is 65, 6, 7, 8. So it's at 68 degrees. So that's a quick overview of how to find the bearing angles and how to draw to scale the resultant vectors, find the distance of the resultant vectors.